Okay, number 11 says solve and graph on a number line. So, number 11 is a compound inequality. So we're going to split it apart and solve two things. So 7 is less than 4x plus 3, and 4x plus 3 is less than or equal to 19. Add 3, so that's 10. Subtract 3, so that's 4. Less than 4x, so 1 is greater than x. Less than x, excuse me. 4x is less than 16, subtracting 3, so x is less than 4. So, I split it apart, I'm going to put it back together. 1 is less than x is less than or equal to 4. So, on my number line, I got 1 and positive 4, open circle on 1, close circle on 4, everything in between. 12, I see an or. So if I subtract 3, I get 5x is less than or equal to negative 10. So x is less than or equal to negative 2. Add 2, so 4x is greater than or equal to 10. So x is greater than or equal to 10 fourths, which reduces to 5 halves. Okay. Negative 2 on my number line. 5 halves on my number line, which is 2.5. Smaller than or equal to negative 2. So it's going that way. Bigger than or equal to negative positive 2/5. 5 halves, 2.5. Alright, number 13 is an absolute value. So I gotta get the absolute value by itself. So this is saying the distance is less than 6. Okay, so 2x plus 4 is less than 6. And 2x plus 4 is greater than or negative 6. So 2x is less than 2, x is less than 1, and 2x is greater than negative 10, so x is greater than negative 5. Now when I put that guy in a number line, I want things that are bigger than negative 5 and smaller than positive 1. So negative 5 is less than x is less than 1. Number 14, I'm going to distance greater than or equal to 3. So 3x plus 6 is greater than or equal to 3. Or 3x plus 6 is less than or equal to negative 3. Make sure you flip both. So 3x is greater than or equal to negative 3. So x is greater than or equal to negative 1. 3x is less than or equal to negative 9. So x is less than or equal to negative 3. Negative 3, negative 1. I want things that are bigger than or equal to negative 1 or smaller than or equal to negative 3. Absolute value by itself. Again, that guy's no solution. I can't go a distance smaller than negative 15. You can't go a distance smaller than 0. Alright, 16. It says graph the relation. Negative 1, positive 9. 7, 8, 9. 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And 4, 9. So, the domains are the x's. Negative 1 and 4. The ranges are the y's. 9 and 6. You could put the repeats on there, but you don't have to. Is this relation a function? No, it doesn't pass the vertical line test. Each x does not have a unique y. So this guy is not a function. Okay, what about y equals 2x minus 7? All right, well it says, let's graph it. So I'm going to start at negative 7 on my y-axis, 2, 3, 4, 5, 6, 7. my slope is 2, so up 2, right 1, up 2, right 1, up 2, right 1. The domain. The domain in the range when you have a line, as long as it's not vertical or horizontal, it's all real numbers. If you look, I can see my graph, and it's going to touch every negative x value, and it will eventually touch every positive x value. So all real numbers. Same thing with the range. It's going to touch every possible y value that's negative and every possible y value that's positive. It passes the vertical line test no matter where I draw my vertical line. I will only touch my graph once. All right, 18. Function notation. So this says use my w function and plug plug 7 in it everywhere I see an x. Okay, so w of 7, so that's negative 2 plus 8 times 7. Negative 2 plus 56, so 54. So w of 7 is 54. I don't do anything with the left-hand side, just simplify the right-hand side. All right, use my t function. Everywhere I see an x, I'm going to replace it with negative 4. Again, your calculator knows order of operations, so you could just plug this guy into your calculator. Make sure you use lots of parentheses because it's negative 4 squared minus 3 times a negative 4 plus 2. So 30. T of y plus 3. So everywhere I see an x, I'm going to replace it with y plus 3. Scoot over so you can see it. Alright, this means I have two of the exact same things, so I'm going to have to FOIL that. I'm also going to distribute a negative 3, so I get minus 3y minus 9 plus 2. Foiling, I get y squared plus 3y plus 3y plus 9 minus 3y minus 7. Final step, combine like terms, y squared, 3y and 3y are going to cancel, plus 3y plus 2. Right. 21 through 25 say, are they linear? If not, explain why. That guy's got an exponent. So now, that guy can be written in slope-intercept form. So that's yes. That guy can be written if we arrange him in slope-intercept form. This guy's got two exponents. He's actually a circle. And this guy's got an exponent, so he's no. Right? 26 says, put the following in standard form. Standard form is ax plus by equals c. So I need my x and my y on the same side. A and b have to be integers, and we like a to be positive. So if I add 4x to the other side, I get 4x plus 1y equals 9, or 4x plus y equals 9. Subtract my 6x, so I get minus 6x plus 1y equals a negative 7. Again, we like our a to be positive, so I'm going to multiply by negative 1. So 6x minus 1y equals 7. X and y have to be on the same side of the equal sign, so x minus 3/4 y equals a negative 1/5. Alright, now I can't have fraction coefficients, so I'm going to multiply by 20 to get rid of the 4 and the 5. So 20x, 20 times 3 divided by 4 is 15, minus 15y. 20 divided by 5 is negative 4. Again, I'm going to move that 2/3 y over, so 4x plus 2/3 y equals 7. I can't have fraction coefficients. Multiply by 3, so 12x plus 2y equals 21. Alright, writing equations in slope-intercept form. That guy's the slope, that's the y-intercept. So y equals 3/5 x plus 2. 31 has an x-intercept and a y-intercept. This guy is also my b value, but these two guys are ordered pairs. So this guy is an ordered pair of 1/3, 0 and 0, 2/5. So I can find my slope. 2/5 minus 0 divided by 0 minus 1/3. So 2/5 divided by negative 1/3. I can't divide fractions, so I'm going to multiply by the reciprocal. And my slope is negative 6/5. So here's my slope. Here's my y-intercept. So y equals negative 6/5 x plus 2/5. Passes through 0, 6. Notice that this is my b, and it's parallel to this guy. So parallel lines have the same slope. So y equals 5x plus 6. 33 passes through 1/8 and perpendicular to y equals 2/3 x minus 1. Okay, well my perpendicular slope is the opposite reciprocal, so negative 3/2. Well, that is not my y-intercept because that guy's not 0. X isn't 0. So y equals my slope times x minus 1 plus 8. Distribute. I'm using point slope form, so 3/2 x plus 3/2 plus 8. 3/2 plus 8 is, what do you call that? 16/2. So y equals negative 3/2 x plus 19/2. There's my point, there's my slope. So y equals negative 5 times x minus 2 plus 5. Distribute that. Negative 5. Negative 5x plus 10 plus 5. So y equals negative 5x plus 15. Alright, passes through 8, negative 3, and 2, 5. So I have to find the slope first. 5 minus a negative 3 divided by 2 minus 8. 8 divided by a negative 6 reduces to negative 4/3. Pick one of the points. So y equals negative 4/3 x minus 8 plus a negative 3. Negative 4/3 x plus 32/3 plus a negative 9/3. Negative 3 is negative 9/3. So y equals negative 4/3 x plus 32 minus 9 is 23/3. Alright, this guy passes through 8, 6 and is parallel to y equals negative 2. Remember, this is y equals 0x minus 2. So the slope of this guy is 0. So if I want something parallel to that, y equals 0x plus all of my b values have to be 6. All my y values, if it's parallel to that. So y equals 6. You could plug it in if you want. That whole thing's going to go away. So you do indeed get y equals 6. Okay, find the x and the y-intercept. This is the one where you might hear me call it the cover-up. Okay, if y is 0, what's x? Well, x is 7. If x is 0, what's y? 7/5. Okay, same thing over here. If y is 0, negative 2x is equal to 11, so x equals negative 11/2. If x is 0, y is 11/8. Remember, these are ordered pairs, so this would be like 7, 0, and 0, 7/5. This guy is negative 11/2, 0, and 0, 11/8. Okay, so 39 says graph each one. This guy looks nice and pretty, so I'm going to use my intercept. So 3x is equal to 15, so x is equal to 5. So it crosses my x-axis at 5. Negative 5y is equal to 15, so y is equal to negative 3. Could you have put that in slope-intercept form? You bet. 40, x is less than or equal to negative 1. I've got an x equals, so he's a vertical line. Oop, that's the wrong spot. At negative 1, those numbers threw me off. I want smaller than or equal to it, so it's a solid line, and I want things that are smaller than that, so shade to the left. We've got an equation of a line. I don't have the equal to with it, so when I graph this guy, he better be a dotted line. So I'm going to start at positive 4 on my y-axis. My slope is negative 1/3. Down 1, right 3. If you go to the right, you're always right. And use a dotted line. And I want things that are bigger than that, greater than, so I'm going to shade low. 42 is an absolute value. Remember, the absolute value gives us that V shape. I'm not adding or subtracting anything, so my vertex is at the origin. That 3 changes my slope, though. So I'm going to go up 3, right 1, up 3, left 1. It's equal to with it, so it's got a solid line. And I want less than, so you can think about shading below your line or outside your absolute value. Okay, 43. I'm going to add 3 so that I have this guy in slope-intercept form. The plus 2 in here means my vertex is going to move to the left 2. The plus 3 means my vertex is going to move up 3. So if I move left 2 from the origin and up 3, my vertex is at the point negative 2, 3. It opens up and my slope is 1 because there's no coefficient.